Okay, so hi everybody, we are MuSa team, and in this video we want you to discover some technical new details about MuSa. As you may remember, MuSa needs to know where you are inside the museum. In order to do that, we collect information inside the museum and send to the cloud a locally pre-processed message. During the last presentation, we closed the technical part with this slide. Today, we are going to start from that point, trying to deeply understand how data flow up and to check what is already there and what is not yet available in our project. Let's start from the script on the left. Here we simulate the device to cloud messages we expect to send from the museum. This small piece of code just simulates the pre-processed messages. Data are mocked up but are already sent to the Azure IoT Hub using MQTT with Azure SDK with the very same interface we will have in the next sprint. Once a message arrives to the Azure IoT Hub, the ASP.NET backend collects it. A receive controller class runs as a native MVC background service on the framework. Once a message arrives, it is saved into the database. Which kind of database do we need? Well, we need fast storage to store temporary data. We need to expose just some of the details of our tour to the client and to process again and store the data in a suitable format for next machine learning analysis in a file. Once a user leaves the museum, this database can be erased for what concerns the user. Due to those reasons, we choose an in-memory database, so we have a DB context containing all the required informations for MuSa to live. So we assume MuSa backend is running. I'd like to focus on the message flow. At startup, the platform starts the service by instantiating the receiver class and calling the preposed callback method. Once the class is created, a service scope factory is injected with a native dependency injection mechanism, and every time a new message arrives, we ask the factory for a new scope so we can always get a reference, of course, to the same DB context running service. We now save the message in the context using entity framework, compressing informations in case we get two consecutive items referring to the same artwork both in the same or in consecutive messages for the same user. We now expose via a REST API required details to the front end. We also have a Swagger to quickly check available calls. Let's quickly try to have a small demo. So this is our Visual Studio Code. In the left terminal, we have the backend code running. So the ASP.NET backend that receives messages from the script. The script is already running in this middle terminal. On the right, indeed, we have the Angular application running. So if we go to the browser, let's refresh the page so that we can go to the home page of the application. So this is the home page. Once a user opens MuSa, he fills a small survey. So for instance, just fill some data, and he asked if he wants a custom tour of each, or if he just wants to collect informations. If he just wants to collect informations, a background service will start collecting information about his visit. Otherwise, if the user fills the survey and wants also a custom tour, he gets a custom tour based on the answers he gave. So submit, he gets a custom tour, and in the Around Me section, he gets details about the nearest artwork. Once he moves, we are simulating movements with the code running here. Once he moves, he get new details about the closest artwork. So we are simulating a user moving between artworks 3, 4, and 5. And that's all. So thank you for your attention.